Hello everyone. I'm Fu Chen from Hosei University in Tokyo, Japan, and I'm very blessed to be able to come to France to give this presentation. The title of my presentation is Partition Frames Downsampling-based video coding with Frame-Recurrent enhancement. This presentation consists of 4 parts: introduction, the proposed method, experimental result and the compression, and the conclusion and the future work. The first part is introduction, the background introduction. With the development of the times, the proportion of video data in network transmission is getting here and here, and a large amount of video data will cause network congestion. So it's necessary to compress the video data. So the most advanced video coding standard in the world is VVC now, which can efficiently compress video data and restore as much of the image as possible to its original appearance. The encoding process is that the image first develop split into many CPU coding tree units, and then for each CTU into many coding units. This step is calculated through the RDU process to find out the best way to split the image. And then other technology of video coding are combined to get the compressed bit stream. And in the decoding of the image, however, the decoded image will have the distortion. It's not clearly. So, and as neural networks are developing faster and faster, some technology on image enhancement have emerged. For example, the DVR video restoration with enhanced deformable convolutional networks. And in these networks have 2 important parts, is the PCD and the TSA. The PCD part model with parameter cascading and deformable convolution, and the TSA function model with temporal and spatial attention. And next, it should be great if we can try to incorporate image enhancement into video coding by combining traditional video coding method with neural network technologies. So the second part is described. Is my proposed method, how we have designed the approach to achieve technology. So in VVC contains 3 configurations: the intro-only, random access, and low delay. And we use the all intro for our case. We use VVC with all intro configuration as the coding base. First, we take 2 frames as a group, and downsampling the middle 3 frames into low resolution images like this. And the first and the last 2 frames remain unchanged, and then put all of these images into a VVC encoder. And then we get the bit stream, and we use the VVC decoder to get the first and the last 2 high resolution frames, and the middle 3 low resolution frames. And then the low resolution frames are upsampling to high resolution frame, which are then put these 3 into all of them into the EDVR process. And the enhancement is done by first enhance the middle frame by referring to the first and the last frame like this. The third low resolution frames be enhancement referring the first and the last image. And then the second frames is be enhancement reference the first and the third image. Like this, the fourth frame is the same process, and then we get the five frames. So our proposed mask is like this to do the video coding. And the third part is the experimental result and the compression are present. So this is the result. This bar chart is represent the number of bits pre-compressed frame. The blue one is the number of the bits in VVC, and the original the orange one indicates the number of bits in our mask. And this line graph uses the vertical coordinate coordinator on the right side is a PSNR, representing the PSNR on the encoding frame. So the line is a PSNR, and the bar is the numbers of bits. It looks like we have reduced both PSNR and number of bits, but actually we lose less PSNR with a large reduction in the number of bits. So this table represents the compression between our encoding mask and the VVC, where BD-PSNR indicate how much our PSNR will be improved when we are both at the same number of bits. And the bit rate indicate how much our bit rate can be saved when both way encoding masks are at the same PSNR. So we can say by those two metrics that our results are better than the VVC encoding results. Some of the results are not high enough, but others are very good results. Is because the videos have different motion, which cause our mouse to get good results. And this four graph correspond to the test result of each video sequence for people or PQ square sum. And the green one is ours, and the black line is VVC's. So we can say we use less bit rate for the same PSNR, or when the PSNR is the same, we do the better bit rate. But no but. So then I have extracted the detail of the results to this image analysis, like this. The C is for the EDVR, the original EDVR version, and the D is VVC version, and the E is ours. So we can say the EDVR, just use the EDVR, have a lot of different, and VVC and ours is the same PSNR, so it looks the same, but our bit rate is better than VVC version. But however, this is not fair, because VVC is all intro configuration only eliminate the space domain redundancy, and doesn't continue to eliminate the time domain redundancy. Where our frame enhancement make use the temporal and spatial attention technology, which is not very fair. Also, our math has made some progress. So then the time domain redundancy is the removal of similar content from frame to frame. VVC's low delay P configuration is only the first frame to be encoded by intro, and subsequent frame are encoded with reference to the previous frame. So therefore, we performed a new round of experiment under low delay P configuration. But one of the biggest problem is this P frame need to be decoded by the I frame. So we need to encode an extra I frame in encoding, which will bring extra bits. Result is not resulting in the bit rate is not good enough and is worse than VBC. But we have another way to solve this problem. We found that the data we transmit contain the high resolution information of the first frame, I frame, and also transmitted the low resolution image of the I frame, which is redundant. So therefore, we propose a P frame way that can solve this problem. The high resolution I frame is used as a reference frame of the P, like this. So although there will be a large loss in PSNR, the bit rate will be improved. This is due to the fact that the amount of the data in I frame is much larger than that in P frame. So we can see the result as shown in this figure. Although our approach doesn't improve low resolution frame to the same level as high resolution frames is the same, but the middle three frame, we can see the number of bits is reduced a lot. In our proposal, our two high resolution frames are same, and based on this reason, we choose to use three downsampling frame in our method compared with the original three frame of traditional VVC. So these two figures show our method bit rate reduction compared to VVC. Like you can see, when the PSR is the same, we use the less bit rate. So it's better than VVC. This table shows the result of so the result for downsampling frames. Just for the downsampling three frames, our method outperform the standard VVC on all intro and low delay P. And the average PSNR improvement to VVC is about 2 dB at a low bit rate, and obtain an average the 61% BD rate reduction under the low delay P reconfiguration, and the result under the all intro configuration are better than that under the low delay P. The all intro is more better. And the last part is the conclusion and the future work. The conclusion is we use a new way to do the video coding by using the network, and we can get a good result. Obtain the results show that we can obtain a BD rate reduced from almost 40% to 85% in all intro and low delay P configuration on the downsampling frames compared to VVC. And we can obtain the average PSNR improvement against VVC from 0.468 dB to 7.67 dB at low bit rate. And at the same time, the obtained results suggest that our method is more suitable for low motion sequence than for high motion sequence. This is affected by the quality of the interframe alignment, which will be the focus of our future work. And the next is the cooperation project. Arba and I are working together on a video coding method for video coding for machine based on VVC. using a model training by Urban to make RDO result suitable for the machine-to-machine communication, improving MIOU results while maintaining or reduced bit rate. And our aim is make the different CTU split away and get maybe the same or over here MIOU results. So our project is ongoing. Thanks for watching. Any questions?
Thank you.
Yes.
I have a first question.
Okay.
What was the complexity of your method? Because from what I understood, at the decoding side, you need to have this the neural network basically.
Yes. Yes.
Yes. The resolution enhancement. And how complex is it? Does it increase the burden of the decoder a lot, or is it a lightweight?
Sorry.
How is the neural network that you are using on the decoder side?
Yes.
Is it a huge one or is it a small one? And how does it affect the complexity of the decoder?
Actually, I'm not thinking about this because the EDVR network is, I'm not sure it's big or small. I'm having other network to compare. So,
are you able to decode in real time, for example?
Oh no, not in real time, because this need a lot of time to do the network to enhancement. Maybe it's the complex is higher than VVC. Yes.
Okay.
Yeah. Thank you for your question. Yes, I will to check the time, the complex. Okay. Thank you.
I have another one. Actually.
Okay.
Is there any plan to do some byte prediction in the VDC? You have the I, the P, and the B frames.
Yeah, I will just.
At the moment, you are only doing the I and T basically.
Yes. Yes.
Do you think your method could also benefit from the byte prediction?
Oh, the backticker is very complex, so yeah. We don't use this configuration. Maybe in the future, we can try for this.
It could help probably to, I mean, if you have two I reference frames, especially when you have a very high motion,
yes,
it might be help to enhance the results that you have in this context.
Yes, yes, maybe it's have a good result. Maybe we need to test in the future. Yes.
I had the same question as Carol about the random access config, but also in your results you show very large gains in bitrate.
Yes, yes, because we just compare the middle three downsampling frames, not the whole frames, full sequence.
Okay.
Yes.
It's not overall. Okay.
Yeah, because like this, we just compare the low resolution frames.
Okay.
So it's better. But in this, we in this part we compare all the five frame, include the high resolution and the low resolution. So it's still higher than VGC.
Yeah.
And
really,
yes, yes.
Because we have had some PhD students working on similar approach, and they didn't get such gains.
Okay, thank you.
And what about the training of your?
Training. By training this, I make the data set by ourselves, because the sequence have a lot of this sequence is the sorry, I forgot. This sequence is for the we're training by without this. Others are the training data set, and this is a test data set, okay, like this. Yes. So maybe half.
So because, for instance, if you take the cactus sequence, it is on the left side. So you mean you have in the training sequence, you remove the best sequence.
Yes. Yes, and when training it, we have to make a different sequence by ourselves. Like this. Thank you.
Any other question? Online, if you have questions, you can just start talking and we will hear you.
Le son il est pas.
Non, le son est là, normalement. Non, le son est là. On a fait le test avec Alban tout à l'heure. So if someone wants to talk online, we will hear them.
Okay. They will.
So if there is no other question, let's thank our speaker again. Thank you very much.
Thank you.